Okay, it's time to start solving trig equations. We're going to start with easy ones, first degree, which means there are no powers, no squares. That doesn't mean there's only one answer, though. It's not like a regular function where you're solving 3x equals 12 and you only get one answer. Because with trig equations, remember, they are not one-to-one, and so there are multiple answers for every trig ratio, depending on the interval over which you're solving. Let me get a couple examples in here. So I'm going to start really simple. Sine of x is 1/2. They're going to give you an interval over which to solve this. Sometimes it's in degrees, sometimes it's in radians, and that's your clue as to what your answer format needs to be. Notice here that 0 is included, but 360 is not, and that is because 360 becomes 0 again. So if your answer happened to be 360 or 2 pi, you need to look here to make sure, should I include it, should I not include it? In this case, it's not included. So our answer is going to be in degrees because that's the interval over which I'm solving. Keep in mind, though, that sine happens twice. These are the 4 quadrants. And sine is 1/2 2 times. Once in quadrant 1 and once in quadrant 2. That is where the sine is positive. And so I know that it's 30 degrees is my reference angle from my chart table. I know that if the ratio is 1/2 and it's sine, that x is 30 degrees. I also know that in quadrant 2, I'm going to get 150 degrees. Keep in mind, we did problems like this. If I give you the reference angle, can you take it back into the appropriate quadrant and then tell me the angle of rotation? And that's essentially what we're doing to find that second angle. Okay, now, if I gave you a sine ratio of -1/2, I still have the same reference angle of 30. Alpha is still 30 because that's the ratio that goes with, 1/2 is the ratio that goes with 30. But because it's negative, now I'm talking about quadrants 3 and 4. And so you need to keep in mind that it takes a little thinking. If I take 30 degrees into quadrant 3, my angle of rotation will be 210. And if I take 30 degrees into quadrant 4, my angle of rotation will actually be 330. And so those are the two answers there. Okay, so depending on if it's positive or negative, you have to be very careful about where are you, what is the reference angle, and then taking those answers into the appropriate quadrants to make sure that you get all answers. Again, if you punch the sine of 210 in your calculator, you'll get -0.5. Same with the sine of 330. And, that comes off our plates also, plates that we made. So here's an example. Twice the cos of x plus radical 3 equals 0. What I'm going to do is solve this for cos of x. So I'm going to move the radical 3 to the other side. It makes it negative. And then divide both sides by 2. And I will end up with cosine of x equals negative radical 3 over 2. And I love it when I recognize the ratio. Radical 3 over 2 goes with 30 degrees for cosine. So I know my alpha is 30 degrees. Because it's negative, I know that I'm talking about quadrants 2 and 3. Okay, so when I take 30 degrees into quadrant 2, x will be 150 again. And when I take 30 degrees into quadrant 3, x will be 210. If you need to draw yourself a diagram, 30 degrees in quadrant 2, this gives me 150. 30 degrees into quadrant 3, this gives me 210. Okay, so if you need to draw a picture, go ahead and do that. Hopefully you're getting more comfortable with this whole reference angle idea, terminal side versus reference angle. So here's an example, and I want to find all angles from 0 to 360 again, so that's still my interval from 0 to 360 that satisfy this equation. First thing I'm going to do is distribute the 2 through this binomial. So I'm going to get 2 sine of x plus 2 equals 5 times the sine of x. I'm going to subtract the 2 sine x from both sides, and I'll get 2 equals 3 sine of x. And then when I divide both sides by 3, sine of x equals 2/3. Okay, now that is not a ratio, I know. So I'm going to tell you to go to the nearest degree on this one. That would have been set up ahead of time. You're going to take your calculator now. If the sine of x is 2/3, when you do an inverse sine of 2/3, you'll get your answer in quadrant 1, because it's positive, to the nearest degree. That will be an inverse sine of 2/3. I'm going to just punch it in here. So that will be 41.8. So if I'm going to the nearest degree, I'm going to say 42 degrees. But remember, that's only your first answer. Sine is also positive in quadrant 2. And so if I take 42 degrees into quadrant 2, when I take 42 away from 180, I'm going to end up with, wait, let me write down my first answer. My first answer was 42 degrees. My second answer will be 138 degrees. And that is from 180 minus 42. Those are my two answers. I want to do a tangent problem, and I want to warn you a little bit about the calculator and how it works. If I'm solving this for x, the x's that make this equation true, and again, I'm going to go from 0 to 360 just for, ease. What I'm going to do is subtract 7 from both sides and then divide both sides by 3, and what I'll end up with is the tangent of x equals negative 7/3, sorry. Now, when you put that in your calculator, if you do an inverse tan on negative 7/3 and round that to the nearest degree, the calculator is actually going to give you a display of negative, one rounded, 67 degrees. Okay, that's because, remember, the inverse tan function, when the ratio is negative, for the inverse tan function, the calculator is going to give you quadrant 4 answer, which is what this is. I don't want a quadrant 4 answer. My answer has to be in this interval. So what you need to understand is that the calculator cannot and will not ever give you an answer that is A, bigger than 180, or B, it's always going to take the quickest route to the terminal side. So what you need to do then is interpret this. Negative 67 is here in quadrant 4. We need to take the coterminal angle to that, so that it is coterminal, so that it is in the right interval, which is from 0 to 360. So we need to go this way and keep in mind that in quadrant 4, that's going to be 293 degrees. Okay, this is actually your quadrant 4 answer. We also need to take this ratio into quadrant 2, because that is the other place where tangent is negative. So when I'm looking at this here, I need to realize that my answers are going to be in quadrant 2 and quadrant 4, because that's the two places where the tangent is negative. Calculator is not going to give up the quadrant 2 answer. So we have to take 67 into quadrant 2, and when you do that and subtract it from 180, you will end up with its coterminal of 113. So my two answers are going to be 113, that's my quadrant 2 answer, and my other answer will be 293. You can check these. You can put in the tangent of 113 to make sure you get the same ratio. The tangent of 293. It's going to be a little off because we rounded, but it'll be close. Okay. If you want to avoid the whole, dumping it into negative 67, and what do I do with that? When you do your inverse, when you find your reference angle, you can omit the sign right here. So if you take the inverse tan of just 7/3, you will get your reference angle of 67. You need to remember, though, that because the ratio is negative, you're taking that 67 into the two appropriate quadrants. So it depends on how you want to handle that. Okay, both will work. One last example here for you. This time I'm going to solve it from 0 to 2 pi, just so that you can see how to finish this off. By doing this, what I'm telling you is that your answer needs to be in radians, and there's no other clue to that except the interval. So I'm going to subtract the 3 from both sides, and I'll get 2 cos of x equals negative 2, and then when I divide both sides by 2, I get the cos of x is negative 1. When you inverse cos on negative 1, the calculator will tell you 180 degrees. You just need to make sure that you put that into radians, and hopefully you know by now that 180 degrees is pi radians. And you're done. We will be solving simple first degree equations, just so that you get used to taking those answers, taking those ratios into to find all of the answers associated in the interval that you're asked to solve.